Atlas has a heartbeat, 16 hours, pulsing, and it might prove everything. July 1st, 2025. Astronomers detect periodic variability in Atlas's brightness. Every 16 hours, the light pulses, brightens by tens of percent, dims, repeats, like clockwork. Scientists assumed a spinning nucleus. They calculated the shape, an ellipsoid with an axis ratio of 0.8. Standard interpretation, textbook explanation. They were wrong. July 21st. Hubble Space Telescope captures Atlas in unprecedented detail. The image reveals something critical. Most of the light isn't coming from the nucleus. It's coming from the coma, the glowing halo surrounding the solid core. The coma dominates. The nucleus contributes less than 1% of the total light at infrared wavelengths, less than 1% from the solid surface. If the nucleus only produces 1% of the light, how can its rotation cause tens of percent brightness variation in the total light we observe? The math doesn't work. The spinning shape theory collapses. The 16-hour pulse isn't the nucleus rotating. It's something else entirely. The heartbeat isn't the body, it's the engine. Here's what's actually pulsing: the jets. Multiple collimated outflows extending millions of kilometers from Atlas, gas and dust expelled at high velocity. These jets are what glow. These jets are what we're seeing brighten and dim every 16 hours. Like a beating heart pumping blood, Atlas pumps gas every 16 hours. The natural version goes like this. A large pocket of ice sits on one side of the nucleus. As Atlas rotates, that ice pocket faces the sun periodically. Solar heating sublimates the ice. Gas erupts. The coma gets pumped up with fresh material. Brightness spikes. Then the rotation carries the ice pocket back into shadow. Sublimation stops. The burst of gas disperses. Brightness drops. Every 16 hours, the ice pocket completes one rotation and faces the sun again. Another pulse, another heartbeat. At 440 meters per second outflow velocity measured by Webb telescope, gas travels 25,600 kilometers in 16 hours. That's the heartbeat range. The distance material can reach during one cycle before the next pulse begins. But here's why the heartbeat pattern proves it's not natural. Natural sublimation requires the ice pocket to face the sun. The jets must point sunward. The heartbeat must align with the sun's direction. Thrusters don't have that constraint. Thrusters fire every 16 hours on schedule, regardless of orientation. The jets can point any direction. Perpendicular to the sun, away from the sun. Arbitrary angles determined by mission requirements, not thermal physics. And we've seen exactly that. Multiple jets pointing in directions that don't align with sunlight. The X pattern extending 1,000,000 kilometers. Perpendicular outflows. The anti-tail pointing toward the sun despite radiation pressure. If the 16-hour pulse corresponds to jets that point sunward, it's natural sublimation. If the pulse corresponds to jets that point anywhere else, it's artificial propulsion. There's a definitive test. Time-lapse images over several days will prove it. Capture Atlas every few hours. Build a movie showing the jets brightening and dimming. Track which direction the brightness pulse propagates. Does the heartbeat pattern orient toward the sun every time? Natural ice pocket. Does the heartbeat pattern point in other directions? Fixed nozzles, firing on schedule. Loeb proposed this test weeks ago. A systematic study. Well-calibrated snapshots over several rotation cycles. Map the orientation of the pulsing jets relative to the sun. It hasn't been done. No published time-lapse exists in the literature. No systematic movie showing the 16-hour cycle and jet orientation over days. Why hasn't NASA released systematic snapshots over days? They have Hubble. They have access to ground-based networks. They coordinated 20 different spacecraft missions to observe Atlas. Why not produce the one movie that would definitively answer whether the heartbeat points sunward or not? Either they haven't collected the data, which is negligent given how critical this question is, or they have collected it and aren't releasing it, which raises different questions. The 16-hour heartbeat was the first mystery about Atlas, detected on day 1. 5 months later, we still don't have the time-lapse imaging that would explain it. We thought the heartbeat was rotation. Hubble proved the nucleus is too small to cause the brightness variation we observe. The jets are pulsing. The coma is being pumped periodically, natural ice pocket facing the sun at regular intervals, or artificial thrusters firing on 16-hour cycles. The difference is orientation. Natural jets must follow the sun. Artificial jets can point anywhere. Time-lapse imaging will prove natural or artificial. Someone needs to do it. The data exists. Multiple observatories have captured Atlas repeatedly. The images just need to be compiled into a systematic movie tracking jet orientation over rotation cycles. December 19th brings optimal observation conditions, Hubble and Webb pointing at Atlas with unprecedented detail. Ground-based telescopes coordinated globally. Make the movie, track the heartbeat, measure the orientation. If the pulse follows the sun, we're looking at exotic ice sublimation from an interstellar comet. If the pulse points anywhere else, we're looking at propulsion systems firing on schedule. Atlas has a heartbeat. 16 hours. Pulsing. The pattern will prove whether that heartbeat belongs to ice or engines. Someone just needs to measure which way it's pointing.